Tray cable is a factory assembly of two or more insulated conductors, with or without associated bare or covered grounding, optional fillers, and binding tape under a non-metallic sheath for installation in cable tray, raceways, or where supported by messenger wire. Tray cable is manufactured in accordance to the UL 1277 listing. All service wire tray cable is manufactured using XLPE insulated solid or stranded bare or tin coated copper conductors. There are 4 considerations when specifying tray cable. Is it CT rated? Does it have UL dual listing? What are the requirements of the application? And is it exposed run rated? CT rated refers to cable tray rated cables. Cables with this designation are suitable for use in overhead or open air cable tray and vertical trays. Single conductors for low voltage power, medium voltage cables, and metal clad constructions can be CT rated in certain size cables. CT rated tray cable refers to power and control cable that is listed as CT rated. The most frequently used tray cables include TC tray cable, PLTC power limited tray cable, and ITC instrumentation tray cable. Article 336 of the National Electric Code identifies where UL Type TC tray cable is permitted. Type TC tray cable can be used for power, lighting, control, and signal circuits in cable trays, raceways, or where supported by messenger wire under certain conditions. Type TC power and control tray cable should be UL 1277 listed, which covers designs from 600 volt/1000 volt to 2000 volts. Products with this listing have been tested and approved by the Underwriters Laboratory, the UL, to comply with the requirements in the National Electric Code. Service wires tray cable is available in 600 volt, 1 kV, or 2 kV rated constructions. The type of tray cable needed may be dependent upon the application. Some cable constructions can be substituted, but the customer must consult the NEC code for proper installation and use of cables. Type PLTC is typically used in industrial control systems, intercom systems, security alarms, and point-of-sale systems. PLTC cables are rated 300 volt and recognized by the NEC in Article 725 and by UL 13. The same constructions and materials used in PLTC cables are also used in ITC cables. Therefore, many PLTC cables have the ITC designation. ITC cables, or instrumentation tray cable, are recognized by the NEC in Article 727 and by UL 2250. These cables are available as pairs or triads in 20 gauge through 16 gauge with overall shield or individual shields. In order to transition tray cable freely between cable tray and utilization equipment or devices, it must have another designation per the NEC. Cables with the TCER, or Tray Cable Exposed Run rating, are permitted to transition distances up to 6 feet without continuous support. The use of TCER rated tray cable will lower labor and material costs over typical installation methods. TCER complies with impact and crush requirements of Type MC armored cable, and NEC Article 336.10 uses are permitted. Per NEC, grounding for utilization equipment or devices must be provided via the conductor within the cable. Service wires tray cable is made of 4 components: inner conductors, insulation, jacket, and an optional shield. Tray cable conductors are most commonly copper, but they can be tinned copper. Tinned copper conductors are primarily used for both corrosion protection and ease of soldering. Copper's combination of conductivity, ductility, strength, and efficiency make it the optimal conductor of choice. Service wire manufactures both bare and tinned copper conductor tray cable. There are 4 different conductor types: solid, concentric stranding, compressed stranding, and compact stranding. Conductors have lower electrical resistance, smaller diameter, and are more efficient when the gaps between each strand are smaller. However, the more compacted the strands, the less flexible the cable. Popular twist options available for stranded conductors include concentric lay and unilay. Tray cable insulation keeps the conductors confined. Insulation resists electrical leakage, prevents the wire's current from encountering other conductors, and preserves the material integrity of the wire by protecting against environmental threats, such as water and heat. The safety and effectiveness of the wire depend on its insulation. Thermoplastic and thermoset are two common types of insulating compounds. THHN is a thermoplastic product. It uses a PVC insulation, which can lead to current leakage and dielectric breakdown in demanding circuits or from moisture or chemical exposure. It is lighter in weight and less expensive to manufacture. XHHW-2 is a thermoset product. Cross-linked products like XHHW have XLPE insulation instead of PVC, which is more resistant to chemicals, ozone, and abrasions. XLPE has a lower dielectric constant than PVC for better performance. Because of the modern chemistries involved, modern XLPE is far less toxic than PVC in the event of fire. Additionally, thermosets offer improved physical and electrical properties and are more flexible at lower temperatures. Cable insulation is also used for conductor identification. Color coding allows you to quickly identify, test, and terminate multi-conductor cables. ICEA Method 1, tables E1 and E2, utilize color to identify individual conductors, while ICEA Methods 3 and 4 use black insulation with printed numbering. Most industrial end users specify ICEA Method 1, table E2 for 14 gauge through 10 gauge, and ICEA Method 4 for 8 gauge through 1000 kc mil conductors. Utilities, on the other hand, specify ICEA Method 1, Table E1 for 14 gauge through 10 gauge conductors, and ICEA Method 3 for 8 gauge through 1000 kc mil. Remember, you should always verify the end user's specific color code methods. Certain applications may require the tray cable core to be shielded. When required, shielding minimizes interference from outside disturbances and keeps inside electrical noise from polluting the environment. Types of electrical interference include magnetic noise, static noise, and crosstalk. The charts illustrate the benefits of a shielded cable versus a non-shielded cable in a factory environment. You can see how the shielded cable reduces electromagnetic interference, EMI, from impacting the cable circuit. Remember, cable shields must be properly terminated for optimum performance. There are 4 common shielding methods: aluminum foil and mylar, used in instrumentation and control; copper braid and foil, used in power, control, or instrumentation; helical flat copper tape for power and control applications; and longitudinal corrugated copper tape primarily used in utility. The shield can be applied helically or longitudinally over the cable core. Helically applied metallic tape shielding is wrapped around the cable core with a specified overlap to provide 100% coverage. This is the common shielding method for industrial applications. Longitudinal copper tape shielding is typically applied down the length of the cable with a corrugated metallic tape to provide both flexibility and added physical protection. This type of shielding is more common in utility substations. All tray cable designs utilize an overall outer jacket as protective covering. These jackets provide the cable core protection from moisture, chemicals, abrasion, flame, and can be rated for direct burial. Selection of the outer jacket compound is dependent on the environment in which the cable is installed, the properties of the compound, the life of the cable, and the ratings required. There are 4 common jacket compounds: polyvinyl chloride, PVC, chlorinated polyethylene, CPE, cross-linked chlorinated polyethylene, XLCPE, and low-smoke zero halogen, LSZH. PVC is a low-cost option and is more durable. CPE is a higher performance jacket. It burns to ash when exposed to flame. XLCPE is used for harsh environments. Low smoke zero halogen does not emit harmful gases or smoke when burned. Outer jackets contribute to a cable's hazardous locations rating. The NEC breaks hazardous locations down into class, divisions, groups, and zones. These classifications allow end users to better understand if the area they are working in is considered dangerous, so that proper cable types can be used for added safety. A hazardous location is an area where the possibility of an explosion or fire exists, which can be created by the presence of flammable vapors or gases, combustible dust, or easily ignitable fibers. The three hazardous locations to consider when selecting the right tray cable from Service Wire is Class 1 Div 2, Class 2 Div 2, and Class 1 Zone 2. Class 1 locations are those in which flammable gases or vapors can be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Class 1 locations are further subdivided into 2 divisions and 3 zones. Refer to the NEC for a complete definition and listing. Class 2 hazardous locations are areas in which combustible dust may be present in varying concentrations. Class 2 locations are further subdivided into 2 divisions. Class 1 locations are those in which flammable gases or vapors can be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Class 1 locations are further subdivided into 2 divisions and 3 zones. Service Wire manufactures 3 different types of tray cable: non-shielded control tray and power cable, shielded control tray and power cable, and variable frequency drive cable. Service Wire offers XHHW 600V/1 kV tray and power cable with PVC, Service CPE, or EnviroPlus low smoke zero halogen jacket. Non-shielded cable is available in 14 gauge through 750 kc mil, 2 to 37 conductors, while shielded cable is available in 14 gauge through 2 gauge, 2 to 19 conductors. Service Wire's XHHW-2 can be used in cable tray, TCER rated or direct burial applications, and hazardous locations designated as Class 1 Div 2 or Class 2 Div 2. Service Wire offers 2 kV rated RHW-2 for variable frequency drive applications. It is available in 14 gauge through 750 kc mil. The cable consists of 3 stranded copper conductors insulated with heat and moisture resistant XLPE, phase identified and cabled together with 3 symmetrical bare copper grounds. The cable core is covered with a copper tape shield and overall black PVC jacket. VFD tray cable is suitable for use in hazardous locations Class 1 Div 2, Class 2 Div 2, and Class 3 Divs 1 and 2. All Service Wire tray cable is manufactured with thermoset cross-linked polyethylene XLPE insulation. Cables are UL 1277 dual-rated 600V/1 kV and available with an overall PVC, CPE, or low smoke zero halogen jacket. Cable can be used in wet or dry locations, indoors or outdoors, or left out in the open in cable tray, raceways, or where supported by messenger wire. Tray cable is used in heavy commercial applications, data centers, food and beverage, metals, pulp and paper, and automation. In summary, tray cable advantages are simple. It offers lower installed costs than conduit and wire and is easier to install and replace. Plus, Service Wire's tray cable is available in utility collar codes, unusual conductor counts, and 4 conductor power sizes. You can specify 2 types of copper tape shielding, request oversized grounds for cables run in parallel, and get competitive pricing compared to THHN tray cable power sizes. All of these advantages create efficiencies in manufacturing and result in lower overall costs.